Say that again?
From a building's point of view, how does computer applications fall into play?
Well, generally in the probably in the last 5 or 6 years, computer-aided drafting has been pretty widespread. But in general, those have just been drafting means. But the computer can do quite a bit more. You can do load calculations. You can do simulations of solar positions on skylights. You can even create intelligent databases to be read by contractors in the future. Can we continue? Or in fact, for instance, we're developing computerized databases right now where the contractor can read the database and he can develop a complete bill of material listing to get every duct and fitting and damper and diffuser on the entire project. And with that information, he can essentially make a quick estimate. He can make a detailed budget and pricing on the job. For that matter, he could take that bill of material listing, he could completely fabricate the entire job and install it. The same intelligent database, if he was to take our drawings, he could go and do scheduling with it. He could even, if he was to input information as he was in the construction process, could get you on any given point the percent complete or the percent fabricated, which allows both him and the owner and even the engineer to have a lot better control over costs, a lot better control over the quality as well as the schedule. And those three items are pretty important to construction nowadays.
What would that do for the building, for the end product?
Well, it certainly gives you a better building. The higher the quality control under the construction process gives a better end result for everybody. You have better coordination. You can even get into use of these intelligent drawings for facilities management, so that over the life of the building, these electronic drawings with their database attached to them could do preventive maintenance scheduling. It could locate, for instance, let's suppose that you had a recall on an actuator of a VAV box. If your database is set up properly, you could search your drawings and find every VAV box that happens to have that actuator number. And rather than having a serviceman search through hundreds of VAV boxes to find out the 6 boxes that have the actuator that's been recalled, you could have your drawings do that. You could search that database and get that kind of information out of it.
Does the computer also help you do a better job as a mechanical designer?
Oh, absolutely. I mean, the redundancy or the repetitiveness of just doing simple tasks, to do area takeoffs, you can do those far quicker with a computer. It's the kind of job that isn't the most glamorous, so it's difficult to get people to do it manually and to be able to have the accuracy that you want. But you can do area takeoffs, you can do solar analysis. For instance, we're doing a project right now that has about 200,000 square foot of skylight over one area. And we did quite a bit of computer simulations on skylights and the position of the sun and the position of the shadowing on the various spaces within there. And if you had to do that by hand, you just wouldn't do it, because the repetitiveness and the overall iterations are just, thousands and thousands of them. So you can definitely do a lot of things that you would never be able to even dream of doing if you had to do manually.
Would you say that the ability to use computers to aid your design basically makes the efficient, cost-effective high-rise a possibility?
Oh, absolutely.
Make that a statement. Let's hear how that would sound.
I repeat the question again.
Say to me that through our use of computer-aided design, we feel we can make a high-rise project better, more efficient, an overall better end product.
Okay. Okay, you want me to put that into a statement as opposed to a response?
Right.
Okay, let me think here. Well, with the use of computers and CAD, we can certainly provide a better and more cost-efficient design for a high-rise building, or for that matter, any other building. things are coordinated better under design stage. You don't have a mechanical engineer showing exhaust fans that the electrical engineer has shown in the wrong location. Drawings can talk to one another. Again, you can get back into facility management that gives you better cost control over the life of the project. You're better coordinated with the architect. You're better coordinated with the structural engineer. You're not running into pieces of steel that you didn't know that were there, because your drawings now can continually have the updated structural drawings within them. So it certainly makes the design process a better design process, more cost efficient for the designer, as well as more cost efficient for the owner.
As a mechanical engineer, designer, what do you like to see in a building? What's a good building? What's a successful project?
Well, generally I'd say most mechanical engineers don't get enough space to do the mechanical rooms the way they should be done for serviceability and for the life of the project. You typically get half the space that you ask for, and generally equipment has to get installed in much tighter locations than you would like. And certainly I realize the cost of equipment space is expensive to build, but it's not uncommon after a space is built for the building engineer to come back and say, geez, it's awful difficult to get to this fan. I now have to, do all sorts of contortions to maintain the bearings on this housing and what have you. So I think I would like to see more space generally be given to mechanical and electrical systems, because space and the amount of serviceability is going to determine over the life of the project how well you're going to be able to maintain that equipment and how well it's going to respond to you from an energy efficiency standpoint.
I have to say, we would take you'd be more